Thanks everybody for coming. Like I said, I'm going to keep it informal. I'm just going to talk to you a little bit about my experience over the 7 years and what I see in the energy storage market, as well as what our company is betting on in the future. Because when you're making an investment, if you're working for a company, what you're looking at in this space is you're looking out 5 and 10 and 15 years. That's just what this space is about. These are big projects. We're talking in the millions, if not multi-million dollars for a single project when you're speaking about grid storage. So you have to plan out a long time, because that's a lot of money. So very simply, to ensure the future of ourselves and our children, we must generate 100% energy from renewable sources. This is a huge goal. If we get there is the question, but in order to do that, we must have energy storage. You've got clean energy, which is predominantly solar and wind, and the challenge with these are they're non-dispatchable energy sources, which means when the sun shines, it shines, and when the wind blows, it blows, versus traditional hydrocarbon, which is you can dispatch it at any time. So if you have a demand situation, then you can dispatch the energy, where this has to take predominance on the grid. So in order to move to 100%, you have to be able to load shift that. So that would be produced during peak sunny hours and shifted to the nighttime in order to actually use it, or else you're always going to be on a hydrocarbon system, because those hydrocarbons will have to work over the nighttime period. So to get you guys excited, if you're here, it's a huge market. So in North America, it's a $455 billion market. World energy market is 3.2 trillion. So if you guys are in this field, you're in the right field, because you guys are going to make a lot of money as long as you're dedicated and you work towards working with really strong companies and getting the knowledge base to put your value at a level where companies like mine look at you guys and say, hey, we're looking for good people. We want to hire you on board, and then that's where you guys have power to negotiate your rates and actually make a good amount of money in this space. And that is expected to increase to by 56% by 2040. So this industry is growing very, very rapidly. Why we need energy storage? Right now, annually, the world consumes 22,000 terawatt hours of electricity, and we only have 0.13 hours or terawatt hours of energy storage. So our demand is 170,000 times what our ability to store it is. It's just, it's basically not even existent at this particular point. Our business is focused on double layer electrolytic capacitors for grid scale energy storage. This is very contrarian to the industry, where nobody has looked at capacitors for grid scale. It's always been thought that capacitors are very power dense, batteries are very energy dense. And what that means is that capacitor systems require a lot more footprint in order to get the same amount of energy storage. And so everybody in the industry has overlooked this, and it's one of our biggest advantages and also biggest challenges, because there's no manufacturing at the level to actually install grid scale capacitance yet, or grid scale level of energy storage in capacitors yet. So the reason we're here and the reason I'm talking is because of the collaboration that we've established. So Jian, myself, and our company have set up this collaboration to look at capacitors in a different light. So everybody looks at capacitors as a similarity to batteries, and the fact is they're separate products. So when people look at capacitors, everybody is trying to get them as energy dense as possible. And the problem with that is that has pushed the price per kilowatt hour to $2,000 to $3,000 off the shelf for capacitors versus $200 for lithium ion. And so there's this huge gap there. And so when a developer is looking to deploy capital, they have to look and value the asset. And if they're paying 10 times the amount, they need to see 10 times the return. And right now they haven't seen that. So because of that, they've all focused on creating capacitors that are more modular. So they try to use the highest quality materials, like activated carbon based on coconut shell, which is 10,000 a ton, and very expensive electrolyte that for a bottle this big would be like $2,000, where we have kind of a different view. Our view is, let's look at the kilowatt hour cost of capacitors and use less energy dense materials that we can purchase a lot cheaper. So we can install the kilowatts a lot less. Even though we're trading off for a certain amount of surface area. As long as the cost is reflected, then we can invest and make those purchases and have a big spread difference from where it is today at 2,000 to 3,000, where we're hoping to get it to 500 or 600 a kilowatt hour. So the case for capacitors as an energy storage asset, like I was saying right now, if you wanted to go to like Maxwell, or if you're Cornell Doubler or Samsung and buy their double layer electrolytic capacitors, you're paying between 3,000 and 6,000 a kilowatt hour. Our design material selection is specifically designed for grid storage. So we're bringing down the cost per kilowatt hour. Our goal is to 600 to 800, so we're only 2 to 3 magnitudes off of lithium ion. Again, with that, and I'll get into this a little bit more later, how the markets actually work and why this is important, but because they're power dense, we can operate within 5-minute duration. So our full bank can be charged in 5 minutes, our full bank can be discharged in 5 minutes. And this is a huge advantage once we get to the market side of this. So our technology specifically is deflection converter technology, and this is where we stand out. So our technology allows, it's a plug-in hardware system for inverters that allows them to operate in the highest efficiency duty cycle. So if you look at inverter technology, during a certain portion of the charging cycle, they can maintain 98% efficiency. And so we can operate our system through that and the full charge cycle through that efficiency. So that's how we're able to hit this number. And again, then that's 96.4% round trip. And that's game changing. That's where we come out, and we are confident that as we get to our next milestones, we are going to be the leader for round trip efficiency in the space. So what is deflection conversion? It's a plug-in technology to inverters, specifically designed to operate with capacitors. And the reason is the low equivalent series resistance of capacitors. If you were to do this with batteries, you'd fry them because they're a chemical reaction where capacitors are an electrostatic field. And the reason we're able to maintain this efficiency is because the charging operation is in the highest efficiency band over the full charging operation. So again, the inverter, we are the deflection converter plug-in, and then that's where we can maintain our efficiency over that period and for round trip efficiency, and that's why we see those results. So one of the reasons I'm here to talk to you guys today is that there's this euphoria about the energy storage space right now. We need it, it's true. But the reality is when you're forecasting 10 years out, you have to think, what's your technology going to be like in that market, not today's market? So right now we have these price signals, and there are big deviations between the low demand side of the day, which is generally at about 10 o'clock, peak demand. You've got solar coming on, and it's brought the price right down to $10 or $15 a megawatt hour average in Lower California. And then at nighttime, when demand kicks up, this price can skyrocket to $100, $200 a megawatt hour. So people see this as a price signal, and they've come to the market thinking that any storage technology can be successful. And the reality is I'm much more conservative. I don't think that's the case. I think we're going to stabilize this grid a lot quicker than people anticipate. And if that's the case, round trip efficiency and flexibility are what's going to dictate the future of profitable energy storage endeavors. So this is the peak that I was talking. This is over a few days, but the reality is this is reflected every day. So if you go and watch, you can go to CAISO, the CAISO, which is in California. You can go onto their real-time trading hub, and you can see the 5-minute intervals and the price change between in the early mornings and at nighttime. And this is what's called the duck curve. So anybody in California knows the duck curve. If you trace it under, it kind of looks like a duck. I don't know. That's what they call it. So the reality is, though, if you're looking from a market perspective, the majority of capacity as well as, or the majority of generation and use is actually procured in advance of the spot market. And it's through bilateral trading agreements between generators and users of power. It's only actually a very small amount that's not procured, and this is what's causing these large deviations in price. The spot market changes, is this non-procured amount. So this is what you have to think about for stabilization. Once this gets stabilized, because the market is generally traded to a certain extent well in advance, once that stabilizes, the market stabilizes. And this is why we have a much more conservative view going forward. So, like I said, we at Atlas Power Generation are taking a much more conservative view of energy storage. We are confident that the most flexible and efficient systems will prove profitable. And what flexibility is it's a few things, and this is kind of a skewed term. Flexibility is not only the ability to respond to the grid use, like so a demand. So if an independent system operator sends out a dispatch to a generator, the ability of it to ramp up is generally referred to as flexibility, but there's also another component of this that nobody is looking at, is the ability of your entire storage bank to fully charge and fully discharge in a given period of time. And that's called your C rating. So, and we were just having this conversation earlier today, batteries, the best ones in the field, generally have a C rating of 1, which means over an hour they can fully charge and over an hour they can fully discharge. We're designing our system to be a C12, which means it can fully charge and fully discharge every 5 minutes. And the reason, and I might as well get into that now, the reason that that's important is because, okay, I guess this is talking about the different stabilizers on the grid, but I'll just go back into the market. So how the market works is it's like a stock market. So you have independent system operators. There's 7 of them in North America. There's the Western Interconnect, there's Texas, and then there's some on the eastern part of the country. I'm not going to name them all. Now what happens is generators sell into the grid at spot market prices, and they're called LMP. And what an LMP is, it's called a location marginal price. So what they do is they line up users of energy and they line up generators of energy, and the point where it converges, they move up to the next cost dispatchable unit of energy, and that's the set price for that node for that 5-minute duration, okay? So what happens is over a 5 or 10 or 15-minute period, you can have big swings in price. You can go from $5 up to $20 and then back negative. So when you're taking batteries that are C1 rated, they have to charge over a full hour, which means that those prices that move, they have to average up. And the same when they sell. So even though you may see prices in the hundreds, if a few of those prices are in the teens, it really drops their price. And so you get this narrowed spread. And that's flexibility. So flexibility is the ability to take your full bank and charge it into the, or sell it into the grid, as well as your full bank and buy it from the grid when prices suit. And so that's what the future is going to be built on, this flexibility and efficiency. So this is what I was talking a little bit about there. So this is a 2-hour window. So generally when people are looking at energy, they're looking over days. So they don't generally break it down into 5-minute periods. But if you look here at the low, I don't see the time here, but you're in the low 30s, okay? And that yellow graph is how long a C1 rated battery takes to charge. So they're buying in the low 30s, but they're averaging up to 36.30. And as well, when they're selling. So if they're selling at, they start selling at $68 a megawatt. This is in megawatt hours, by the way. And then they have to sell over that period of time because they're scheduled in. They actually average down to $44.89. So you see the averaging effect that I was talking about there? So now let's take the business case. If they're getting 23.66% return from buying and selling, and some of these technologies have 15 to 20% losses, that means they're only getting a gross margin of 3.6 to 8.6%. So now you think your installation, you have to get a return for your investors, you have to maintenance and operate that, breakdowns. That's why a lot of assets right now even aren't that profitable, or they're barely profitable. It's because they're not getting the returns. And virtually all technologies right now take hours to charge and discharge. So without the pun, we are the high efficiency, high frequency traders of the world's energy markets. Thank you.